Production of biogas. Biomethanation. In this method, organic waste like vegetable matter, crop residues, and animal waste like cow dung are decomposed by bacteria in the absence of air, that is anaerobic, to produce biogas, which contains 70% of methane gas. The gas can then be used for cooking, lighting street lamps, producing electricity, etc. The slurry, which is solid residue left after decomposition, can be used as manure. Disposal of liquid waste. Liquid waste that are produced on large scale are responsible for the pollution of water bodies like lakes, rivers, and seas. These wastes may be liquid or semi-solid. Eutrophication and biomagnification are some of the outcomes of discharging untreated liquid waste into the water bodies. Not only is aquatic life destroyed, but also toxins reach human beings through the food chain, which means it's very dangerous. Thus, it becomes absolutely necessary that sewage and other industrial effluents be properly treated, rendered harmless, and then released into the water for disposal. What are drainage systems? Let's learn about them. Drainage systems are designed to remove surface or subsurface water from residential, industrial, or agricultural areas. The main principle behind any drainage system is to provide an open, suitable, readily accessible channel into which surface water or excessive water from the soil can readily flow. Drains and channels help to remove excess water from marshes, wetlands and land which suffers frequent flooding. Proper drainage systems help to prevent soil erosion also. Types of drainage system. There are two types of drainage system: small-scale drainage and large-scale drainage. Small-scale drainage. Small-scale drainage is carried out on agricultural lands by farmers to remove surface water from fields. Large-scale drainage. For large-scale drainage, it is better to improve the natural stream channels so that large amounts of water can be drained away without causing any damage. In order to drain flat lands, a main drain is laid on one side of the plot and a number of transverse drains are connected to it. These lateral drains are made parallel to the main drain and eventually join the main drain at the lower end of the field. In cities and towns, a proper drainage system consists of drains running parallel to the roads, and these drains eventually join underground drains beneath the roads. The underground drains then open into water bodies like rivers, lakes, etc. Effect of drainage system. Proper drainage in fields helps in the following ways. A. Prevents soil erosion. B. Prevents excessive accumulation of water-soluble salts. Proper drainage in cities helps in the following ways. A. Prevents flooding during monsoons. B. A clean, hygienic environment is maintained. Drainage in cities and towns. In cities and towns, there are two systems of drainage. The stormwater drainage system, which is SWD, and the wastewater, that is sanitary drainage system. First, let us learn about stormwater drainage system. This consists of a network of structures, channels, and underground pipes that carry stormwater or rainwater to ponds, lakes, streams, rivers, or wetlands. Inlets to these channels are located at the curbs, yards, or open pipes near roads, homes, and industries. The wastewater, that is sanitary drainage system. This consists of pipes that carry water and waste from drains connected to sinks, bathtubs, showers, toilets, etc. to a treatment plant to be treated and filtered. It is a closed pipe system accessible through manholes. Stormwater does not flow to a treatment plant. Disposal of biomedical waste. Biomedical waste consists of waste generated from hospitals, clinics, dispensaries, veterinary institutions, pathological laboratories, blood banks, etc. during diagnosis, treatment or research of human and animal diseases. This waste can be in solid or liquid form. The best way to dispose of biomedical waste is by incineration and burial. Liquid biomedical waste can be disinfected and discharged into drains. After incineration, the waste can be sent to landfills. The following table shows some of the different categories of biomedical waste and the treatment. Category and treatment of biomedical waste. Now here are the categories, and this is how biomedical waste are treated. Human anatomical waste. Human anatomical waste is treated by incineration and burial. Animal waste. Animal waste is treated by incineration and burial as well. Biotechnological waste. Biotechnological waste is treated by incineration. Discarded medicines. Discarded medicines are treated by incineration and disposal in landfills. Solid waste from blood and body fluids. Solid waste from blood and body fluids are incinerated or are treated by autoclaving. Disposable items like syringes, tubes, etc. Disposable items like syringes, tubes, etc. are treated by disinfection and shredding. Liquid waste. Liquid waste is disinfected by chemicals and discharged into drains. Chemical waste. Chemical waste is discharged into drains, and if solid, then into landfills. Constituents of biomedical waste. Biomedical waste usually contain heavy metals like mercury, chemicals, preservatives, for example, formalin, most of which are carcinogenic, that is, cancer-causing. Plastics, which when burnt, produce harmful chemicals called dioxins and other pollutants that are harmful for human health and a threat to the environment as well. Management of air pollutants. Scrubbers. The scrubbers are devices to remove gaseous and particulate air pollutants. In these, the air is passed through a dry or wet packing material of a typical scrubber. The air passing out of the scrubber is dust-free, clean, as well as free of certain gaseous pollutants which get dissolved in the wet packing. Electrostatic precipitators. The dirty air containing particulates is passed through a chamber containing electrically charged plates. The particles may be naturally electrically charged and as they pass through the charged plates of precipitators, they get collected on the plates carrying opposite charge and the clean gas passes out. The electrostatic precipitators can remove up to 90% of particulate matter from thermal plants.